Okay, so there's 4 different kinds of change we're going to study here. So first, let's talk about linear change. Now, linear change we talked about in the fall. And linear change, there's 2 kinds of change. There's positive change and there's negative change. So with positive change, each time the x value increases by 1, a constant value is added to the y value. So for example, a tree starts at 10 feet tall and grows 4 feet each year. So what's that going to look like? Well, the tree starts at 10 feet tall at year 0. And then after 1 year, it's 4 feet taller, so we're adding 4. And then after the next year, it's 4 feet taller, we're adding 4. And after the next year, it's 4 feet taller, we're adding 4, okay? Something is added each time. So the table looks like this. Now, with positive linear change, the equation is going to look like y equals mx plus b. And this number, because the change is positive, this slope is going to be positive, okay? So, for example, in this case, right, this is the starting point. So my starting point in this example is 10, and then it's going up by 4 each year. So this is an example of what this equation would look like. And what does the graph look like? Well, it usually looks like this. It's a straight line, and it's going up, right? The slope is positive. Now, we've also talked before about negative linear change. So in this case, each time the x value increases by 1, a constant value is subtracted from the y value. The y value is going down. So for example, if Ashley has 50 candies from Valentine's Day, she starts with 50, and then she eats 3 each day. We're subtracting 3, right? After 1 day, she has 50, then she ate 3, so now she has 47 left. Then she ate another 3, so she has 44 left. And she ate another 3, so she has 41 left. Okay, now this is still linear change, so we're still using y equals mx plus b, but the difference is now that this number, the slope, is going to be negative. So for example, in this particular problem, the starting point is 50. Okay, the starting point is 50, and the rate of change is -3. There's candies, we're losing 3 candies every day. So the rate of change is -3. Okay, and what does the graph look like? It usually looks like this, where it's a straight line and the slope is negative. So the line is going down from left to right. Okay, now exponential change, this is new. So there's exponential growth and there's exponential decay. Okay, and you can see this fly is flying around right here and actually bothering me. Okay, so growth is every time the x value increases by 1, the y value is multiplied by a constant value, okay? So, for example, at noon, there are 100 people tailgating at the Super Bowl, right? So there's a bunch of people, they get there really early, and so at noon there's 100 people there. And then what happens? Well, as the game gets closer, right, the next hour, more people arrive. Look, it says that number triples. What does that mean? Triples means multiplies by 3. So at 1 o'clock, there's 300 people tailgating. I'm multiplying by 3. At 2 o'clock, there's 900 people tailgating, right? And by the time the game is about to start at 3 o'clock, there's 2,700 people tailgating, okay? Notice this is times 3, times 3, times 3. Now, what does this equation look like? This equation looks like this, and this is new. Okay, this is the form of the equation. This is going to be the starting point. This is going to be the starting point, and this is what's called the growth factor. Okay, it's growing. The amount is growing. Okay, so for example, here, the starting point is 100, and the number is growing. It's growing by 3. It's being multiplied by 3. Okay, now look, this makes sense. Like, we can think about how this equation actually makes sense because, right, this, when x is 0, this is 100 times 3 to the 0. That's 100 times 1, which is 100. Then it becomes 100 times 3. Then it becomes 100 times 3 times 3. Then it becomes 100 times 3 times 3 times 3. So this x is making me multiply by that 3 again and again. The graph for these looks like this. It kind of like starts like a little bit like a slow, and then it goes whoop, and it grows super fast like that. Okay, so the graph looks like this. It's kind of like a curve. And then the final type of change we're going to be looking at is called exponential decay. Now this time, rather than being multiplied, a value is being divided. So for example, if a landfill has 1,000 tons of garbage in it, right? What happens to that garbage? Well, it biodegrades. It just turns into dirt and soil, right? But it takes a lot of time. Okay, so each year half the garbage in the landfill biodegrades, right? So the first year, a lot degrades, half of it. So we're down to only 500 tons of garbage. And so all the, like the food stuff and paper stuff that degrades easily will decay. And now after the next year, there's 250 tons, okay? Notice it's getting cut in half. It's getting cut in half. And the next year, there's 125 tons, okay? Notice I'm dividing by 2, dividing by 2, dividing by 2, okay? The form of the equation is the same as this, okay? But this is called the decay factor. And this will be less than 1. Okay, this will be less than 1. The growth factor is more than 1, right? Like here, the 3 is more than 1. This decay factor is less than 1. It's going to be a fraction. So like, for example, in this case, the starting point is 1,000 tons of garbage. And what's it being multiplied by, right? Look, this is 1,000. It's going to be 1,000 times something. What it's being multiplied by is a half, right? 1,000 times a half is 500. Multiplying by a half is the same as dividing by 2. So it looks like this. Okay, and what's the graph going to look like? The graph looks like this. It kind of starts big, right? Comes down pretty fast, and then like this. So it looks kind of like a mirror image of that growth graph. Okay, so we're going to be able to recognize these 4 different kinds of growth and be able to recognize it in a table and in an equation and in a graph.